Ladies and gentlemen, I think it is a universal experience to be in school and think something on the lines of, why am I learning this? And even as grown-ups, we think, man, I forgot 90% of what I was taught in school. One day, as part of my school reviews, I asked my teacher, why do I have to learn French? I just want to be a video game designer. He simply answered, what you don't know will be used against you. At the time, I did not understand what he meant, but for the past 7 months, that phrase has been hitting me every day. During my research to disprove the Academy of Nutrition and Dietetics, I came across a giant in the industry, Professor Christopher D. Gardner, PhD. A giant because Dr. Gardner is one of the scientists most involved with nutrition research, and his focus in pursuing real science is absolutely admirable. Yes, he has been in the past backed by vegan companies. I truly believe Dr. Gardner is looking into trials with a critical eye. However, I believe Dr. Gardner has been a victim of what you don't know will be used against you. In order to understand this video better, a bit of biochemistry is necessary. Let's learn in very basic terms about protein synthesis. A protein is just a 3D structure made by a line of amino acids that folds and refolds itself into a specific shape. The order in which the amino acids are put together will create different shapes. And, depending on the shapes of the protein, this will have different functions. But how does your body know how long a protein should be? And how does our body know the order in which to put the amino acids? With 20 different amino acids to choose from, and some proteins having hundreds if not thousands of amino acids, this process is actually very interesting. The RNA has a start code that something called the ribosome will attach itself into to start creating a new protein. The ribosome will read the code and reject all the amino acids that do not match the code, accepting only the ones that do match. Then, moves on to the next code, and again, only accepts the matching amino acid. This will create a chain that once the ribosome hits the code for stop, it will release the chain of amino acids that will fold itself and create a new protein. It is fascinating how these little machines inside our body create these proteins, and they do it millions of times every day. But, if nothing else, please bear in mind that these little machines are not really conscious. The ribosome does not pick the amino acids that it needs. It checks the ones that it encounters until it finds the matching one in a somewhat random behavior. Now, why am I telling you all of this? In his paper, Dr. Gardner claims that matching vegan proteins is more than enough for our bodies, and that animal protein is not only unnecessary, but also harmful for the environment and yourself. Dr. Gardner is cursed with the assumption that saturated fat is harmful, cholesterol should be kept to a minimum, and that animal protein is causing global warming. In spite of all this, I want to focus on his comment regarding protein quality. Here is what Dr. Gardner has to say to those who reject the power of matching different plant proteins to obtain the same quality as animal protein.
All proteins are made of 20 amino acids in the human body, and I like to think of them like Scrabble letters. All of the plants have all 20 amino acids. The distribution of the amino acids is almost identical in the plants as the animal. Rice and other grains in general tend to be low in the proportion of lysine that they have relative to the optimal proportion. And likewise, beans tend to be low in methionine and cysteine in proportion to what they need. And so I like this Scrabble analogy. So picture that you've had this Scrabble game for a really long time, and you lost the L for lysine and the M for methionine. Are you missing all the L's and all the M's? No, actually, you only lost a couple of the letters. So if you were using your board and trying to make words, you would run out of words you could make with L and M sooner. What if you had a neighbor who also hadn't played Scrabble in a long time, and they said, oh, I'm so sorry you're missing those letters. You can have my Scrabble bag of letters. Oh, I'm also missing an L and an M. I'm sorry. You could still fill up the L and the M that you were missing because your neighbor has extra L's and M's. And so I'm thinking, what if you had 2 bags of Scrabble letters? Oh, that's like what Americans eat in protein every day. 2 bags of Scrabble letters.
I think that the words and letters analogy is really good to understand the proteins and amino acids. However, as soon as he said something like, you have 2 bags of Scrabble, my alarms went off. Anyone that has studied probability and statistics knows that what he says cannot be completely true. Adding more variables does not automatically mean that you have more chances to complete your task. In our Scrabble example, imagine that we are trying to create a protein named protein. Animal foods have the perfect amount of amino acids for our body, which means in our example that the letters given to us by animal protein would be P-R-O-T-E-I-N. And the more you eat, the more protein words you can write. Whole plant foods, however, have an off combination of amino acids or letters. Beans, being weak in methionine, for example, would be like us getting an extra I and N instead of an O. And you can eat more beans to get more O's, and in Chronometer, it will say that you ate enough protein, but your body will not have enough pieces to build the proteins it needs. This is where mixing and matching proteins comes along. Dr. Gardner mentions in his paper that eating beans with bread would compensate for the amino acids needed in beans. In our example, the bread would provide us with the extra O's needed, plus a few more letters. But I would argue that eating more plant protein will cause the protein synthesis to get worse. Not based on any studies, but simply on the basis of statistics and probabilities. Remember, the ribosome creating the protein does not choose the amino acids that needs based on a pool. It bumps into the amino acids and rejects those who do not match with the appropriate time. Also, the ribosome cannot jump ahead and save the needed amino acids for later. The ribosome has to randomly find the needed amino acids and match it at the perfect time, otherwise it cannot continue, and it slows down protein synthesis. Because plant protein has a different set of letters, this makes the whole process much slower. More letters does not equate to a better chance, and this is something that you instinctively know if you had some basic probability knowledge in your head. But I was never really good at calculating the probabilities, so I decided to make a physical test. I wanted to create two words just like the ribosome would. Pick a piece at random. If it is the correct letter, put it on the board. If not, make it rejoin the pile. Again, pick randomly until I get to complete the word protein twice. Eating animal protein is just like having the perfect matching letters. So, in the animal protein experiment, I had 2 P's, 2 R's, 2 O's, 2 T's, 2 E's, 2 I's, and 2 N's. In the plant protein, I had the same letters, plus an extra I, E, N to represent the amino acids you get from mixing and matching plant proteins. This was the result. Even though the plant side had more amino acids, when pulling them randomly, just like our body does, the animal side always finished their words faster. Now you might think that this does not really matter, because the delay is not that big. But imagine this delay happening thousands of times per day in your body throughout your whole life. One such effect can be seen on wound healing. Scarring in your skin and organs happens when a wound cannot heal fast enough, and our bodies patch it up in order to prevent further damage. With protein synthesis being responsible for your hair, nails, skin, heart, brain, hormones, and so much more, imagine always being slightly delayed to everything that your body needs. What you don't know will be used against you. Dr. Gardner's lack of consideration from statistical probabilities created a huge hole in his hypothesis that he could not even consider. This knowledge alone should be a huge detriment in recommending vegan proteins as good sources of protein. There is also one more thing that Dr. Gardner did not take into consideration. Our body can store carbs and fat. We cannot store protein. The amino acids need to be used as they pass by our bodies, or our kidneys will filter them. This means that while amino acids from animal protein arrive in the correct quantities and always together, plant proteins will have different timings due to different digestion properties. Bread gets into our bloodstream much faster than beans, meaning that eating them together might not be the most efficient way for our body to use the needed amino acids. This last argument is a bit weak, since if you have a balanced meal 2 to 3 times a day, there should be no timings problem. However, how many people nowadays have a balanced meal 2 to 3 times a day? I see it as a game of Tetris, where omnivores can easily clear the board, while vegans have to work extremely hard, and, as they slip up, the mistakes will start to accumulate until one day the game is over. In the next video, we will go in depth into this paper, which I find so interesting, and I hope you will too. After all, any paper that puts in its sources the position of the Academy of Nutrition and Dietetics, for me, is something very amusing. I'll see you in the next one.